Well, in this video we are going to discuss properties of the standard deviation and variance in detail. First of all, we will describe it, and after that we will verify it using Microsoft Excel. First property of the variance and standard deviation is that the constant, the variance and standard deviation of a constant is always equal to 0. So if a is any constant, then the variance and standard deviation of constant is always equal to 0. Why? Because variance and standard deviation is a measure of dispersion, right? And dispersion arises when the values exceeds 1. Since for one value there is no dispersion, one value cannot be deviated from itself, so that's why there is no dispersion in a single value. So the variance and standard deviation for a single value is always equal to 0. The second property of variance and standard deviation is that if we add any constant or we subtract any constant from the data, variance and standard deviation will remain unchanged. For example, if a is any constant, right, and suppose we add it or subtract it from this data, x is a variable which is a data set. So if we add or subtract any constant from this data, variance and standard deviation for the same data remains constant. I mean, if constant is equal to 2 and we add 2 with the data or we subtract it from the data, variance will remain unchanged. So before adding or subtracting and after adding and subtracting constant from the data, variance will remain unchanged, and we will verify it with Microsoft Excel. Third property is if the data is multiplied by a constant or if it is divided by a constant, variance and standard deviation will be changed by the square of that constant. For example, if data is multiplied by a, then variance will be changed by a square time variance of x. And similarly, if the data is divided by a is any constant, then variance will be divided by the square of that constant. So this is the property. For example, if a is equal to 2 and we multiply the data by 2, then variance will be 2 square time variance of x, or you can call it 4 time variance of x. Similarly, if you divide the data by a constant, for example by 2, then variance will be changed by 1 over 2 square, right? If the constant is 3, then variance will be changed by 1 over 3 square, that is 1 over 9 time variance of x. But this time we are dividing the data by 2, so variance will be changed by the square of the constant. So variance will be 1 over 4 time variance of x. Next property is if we have two samples, that is n1 and n2, and it yields sample variances s1 square and s2 square, then the combined variance is noted by VARC, and it is equal to n1 minus 1 time s1 square plus n2 minus 1 time s2 square to be divided by n1 plus n2 minus 2. So this is the formula for the combined or pooled variance, and this rule can be generalized. And the last property is if there are two variables x and y, and then the sum of the, if we sum them up or if we find their difference, the variance of their sum is equal to the variance of the sum of their separate variances plus 2 times covariance of x and y. Similarly, variance of x minus y is equal to the sum of their separate variance minus 2 times covariance of x and y. Where covariance, what is covariance? Covariance measures the degree of association between x and y, and it is always calculated by summation xy divided by n minus summation x divided by n into summation y divided by n. And the same properties applies for standard deviation as well. Now we are going to verify these properties using Microsoft Excel. Before further discussion, you guys are requested to like this video, subscribe to Shaw Academy, and press the bell icon to get regular updates of this channel. This is the Microsoft Excel data, and x is the variable which shows marks of the students from exam. Now, for the sake of properties, I will generate more variables from this variable. That is, I will add a constant, let the constant is equal to 2. So if we add 2 with x and we name it y1, so y1 is a variable which is equal to x plus 2. So we can add 2 with all these values. So it will be a new variable. Similarly, we can subtract a constant from the same data. Let the constant is 5 this time. So this is the second variable. The third variable is x is multiplied by 2. So y3 is equal to 2 times x. Because we have to test whether if the data is multiplied by a constant, we have to test whether variance is changing by the square of that constant or not. Similarly, we can divide the same data by a constant. Let the constant is 3 this time, right? So these are 4 different variables which are generated from x, and now we are going to verify the properties. So first of all, we need to find out the variance of x. So this is equal to var dot p. For population variance we put dot p. For sample variance we put dot s, because you can see two options, dot p and dot s. So you can calculate sample variance, you can calculate population variance. So I put dot p, and the data is this, the data, bracket close, and the variance is equal to this value. So the variance of x, this is the first variance. Now we have to find out the variance of all these values. Locate it. This is the same data, but I have added a constant with it. So according to the property, variance should remain unchanged. So equal to var dot p bracket, and now again you can compare the two variances. Both the variances are the same, despite this data is generated such that 2 has been added with each and every value of x. So the variance of y1 is exactly equal to the variance of x, despite constant has been added to the same data to generate y1 variable. Similarly, if I find out the variance of this column, again it must be the same according to the property. Why? Because according to the property, if we subtract a constant from the data, variance should remain unchanged. So equal to var dot p, and the data set is this, and locate it. Again, this is the same. This variance is just similar to this, is just similar to this. So if you add a constant or if you subtract a constant, variance remains unchanged. So this is the verification of the first property. Now if I find out the variance of this, it will be changed by the square of the constant. For example, if you find out the variance of this, let us first find out the variance of this, or let us confirm this. I have multiplied the data by 2, so variance should change by the square of 2. What is the square of 2? Square of 2 is 4, because 2 square is equal to 4, into variance of x is equal to this value. So the variance of this variable must equal to this value. Where this value has come from? It is equal to 2 square times variance of x. So if I find out the variance of this, it must equal to the same value as 87.47. So equal to var dot p, and compare the two values. This is 87.47 and this is also 87.47. So this has been verified. Now look at the other property. According to this property, variance should be changed by the square of 3. So what will be the answer of this? What will be the variance of this value? It must equal to 1 over 9 times variance of x, because I have divided the data by 3. So variance will be divided by the square of 3. What is the square of 3? 9. So if I calculate it at advance, equal to 1 over bracket 1 divided by 9 into variance of x. Variance of x is equal to this. This is 2.47. So according to the property, if I find out the variance of this estimate, it must equal to 2.42. Let us verify it. Equal to VAR dot P bracket. Now compare the two values, they are just same. So this is the verification of the property. Now turn to next property. According to next property, there are two variables x and y. Okay, we are summing them up and we are subtracting them. So we generate another variable, that is x plus y and x minus y. And according to the property, variance of x plus y is equal to the sum of their separate variance plus 2 times covariance of x and y. Similarly, according to the property, variance of x minus y is equal to the sum of their separate variance minus covariance time 2 times covariance of x and y. So let us verify it. First of all, I need the left hand side. So finding out its variance, it is equal to VAR dot P, and the variance of x plus y, this is equal to this 27.4. Alright, now we need the variance of x and the variance of y. So equal to VAR dot P, and this is the variance of x. Now the variance of y, if you drag it to the right hand side, you will also calculate the variance of the right hand side. And this is the covariance which I have already calculated in advance by this formula. This is the covariance of, this is 2.45. This is the covariance. Now look at it. It must equal to, according to the property, equal to x plus variance of y, or plus 2 times covariance of xy. Covariance of xy is already calculated, which is equal to 2.45. Now you can compare the two values, 27.4 and 27.4. So this is the verification of the property. Similarly, if you find out the covariance of x minus y, you can drag it to the right hand side so as to directly calculate the covariance, the variance of x plus y. This is the variance of x minus y, sorry. According to the property, it must equal to variance of x plus variance of y, or minus 2 times covariance of x y is equal to this value. If I click enter, it must equal to 17.6. So this is 17.6. So the difference between these two formula is here plus 2 covariance of x y, and here minus 2 covariance of x and y. So this is the verification of the properties of the variance and standard deviation.